Welcome to the 6th video of the IoT in Practice workshop. Today we are going to add sensor data reading to the system we are building. Let's get started. If you are wondering how professionals create electronics without chaos and with maximum collaboration, the answer is Arduino Develop. Imagine an environment where you eliminate the problem of manually emailing files to others, such as mechanical engineer for PCB verification, and start working in real time in one cloud. Arduino Develop is an advanced professional central hub that integrates the PCB design tool with the broader ecosystem. With it, you can forget about the frustration and delays that come from constantly losing context and having to manually track corrections. We will be reading data from an air quality sensor, a humidity and pressure sensor, and sensors for light intensity and sound levels. Let's place them on the breadboard and connect them according to this diagram. First, let's configure the ENS160 sensor. It communicates with the microcontroller via the I2C protocol. Let's install its library and upload the included example code. As you can see, the data collected by this sensor is now being displayed on the serial monitor. Now it's time for the BME280. It also communicates with the microcontroller via I2C. We will follow a similar process: install the library, upload the example code, and observe the results. Next is the BH1750, a light sensor that also uses I2C. We install the library, upload the test code, and check the readings. Let's cover the sensor to see if the values change. Great, it's working. Finally, the MAX4466, a microphone with an amplifier. We read data from it using the ADC, analog to digital converter. Simply connect it to an analog input and use the analog read function. On the serial plotter, we can see how the signal changes in real time.